In Qt, we will see event-based programming. We have already seen about layouts and widgets in the earlier discussion. And we will see that how we can connect certain things which we are going to learn today. So what happens when a user clicks a button or enter something in the text box or do some mouse hovering at certain specific area? In C in and C out, we just enter values. Screen will come, we enter value, and the computation will go on. But what about the case when you are actually working on a GUI? So we do stuff using our event-based programming. So some event happens, and on account of that event, action does take place. Let us assume that you have your function says foo. What you would like to do is for foo is to be called by any time a user clicks a specific button, and it's quite simple. Those people who are doing IDE or you are using NetBeans or Visual Studio, they know that on clicking a button, a function can be called. Now, the folk who wrote the QPush button, a person who has written this QPush button class, has no idea about what function you are talking about, the foo. So they have not added any code anywhere in your QPush button to call your foo. So how then you get the code for calling foo? Means you want to press a button, you want to call a foo which is there, but QPush button has nothing to do with it. Now the way is to do this particular task is to register your foo, that is the function, with your button. You ask or you intimate the compiler to connect the event for pressing the button with this function which you have developed called foo. This following is not exactly how Qt does it. This is very important. That is why I am emphasizing. Perhaps it illustrates the underlying concept. Why? I'm going to tell you. Because it cleans those two, it aparts. It makes a clear distinction between your GUI and your functionality. So we could add our QPush button class, a function which is like that. Add function to call when pressed, and inside this you have this void function call f. Now you need to remember how you saw function pointers before. This is how this would be where they come quite handy. And then in your my push button you can just call this function which you just have made, add function to call when pressed, and inside this you can call foo because this is already a statement here. Now this my push button is actually a Q push button because Q means it is a Qt button which could internally store a list of function pointers, and then all of them get called anytime someone presses the button. So this is not only one, you can have various function pointers. So as long as your function foo is of type void, which we have made with no parameters, this will all work fine. But there are some reasons not to do it this way, and a somewhat more elegant solution to this is already there. In Java AWT we used to do something like this only, and we can define an interface. Now this is a good idea, but I'll show you how we'll do it as in Qt. So we define an interface that is completely abstract class. Interface is a completely abstract class. Only we have virtual with is equal to 0 function inside it, and we call them runnable as follows. We call it class runnable. Inside this we just place a line virtual void run is equal to 0. So any object can be of type runnable so long as it has run function, because we have this runnable class. Now we could add in this QPush button the following function, because this was the function. We will add this runnable and a pointer to this. Now rather than calling our function foo and making it a global function, what we can do is we can just define a class like this. Class foo class public runnable void run virtual void run, and we can place our previously we code here that was previously in void foo, we can place it right here. Now if we define an object FOO object of type FOO class, this object, any object it can be, we can add my push button dot add object to class when pressed, and inside this we can pass a reference of this object. So internally what is going on, QPush button could keep a list of objects of type runnable. Anytime the button is pressed, the QPush button object could go through its list, and for each member of the list which are there calls the function of run, which must exist because the type object is of type runnable. So this would be quite a elegant way to establish the connection between the button which is pressed and the function which is going to execute. So this you have seen, you have buttons which are programmed before the functionality they are supposed to cause. All they know is that there will be some other objects whose function they are supposed to call. So you have objects which we just made of type runnable, which will implement the actual functionality you want. They don't need to be aware at all whether they will be called by buttons or menu buttons or any other thing. So all they know is that whenever this run function gets called, they have to do some useful work. So we have cleanly separated. This was the idea. The discussion was only because of the conclusion which I wanted to make, that cleanly separating the GUI from the actual functionality. Yet we can connect them because everyone is implementing a specific interface or function. That is adding a function to a call and then run function. This kind of paradigm is the heart of event-based programming, cleanly separating the GUI from the functionality. So what we have just talked about this at length. Now, how does Qt implement it? The basic question is this. The approach is based on, we call them as signals and slots. What are signals? They are emitted or fired by widgets, and slots, they are the functions that they get called when the signals are emitted. So Qt then need to connect these two with each other, means signals and slots. So it's important to consider that one signal can be connected to many slots. Just take an example, when you press a button and many functions could get called. And a slot can be connected to many signals as well. Just consider that the similar function could get called when you press a button or say any other widget. No? So signals, to define a signal inside your object, you use a keyword signal. Keyword signal. Let us define a class called sender. This is public queue object. You have to place a queue object. I'll tell you what this queue object is. Then you have a sender. Inside this, you have another function in this public access specifier, send a signal. In this you have number, and then you are emitting send number. Then you have signals which is sending some number, some k. So what to know about this? The first queue object is just a keyword that you need to put in anytime you want Qt to do some pre-compilation of Qt syntax. Then we have keyword signals. Is not actually C++, because if you want to run GCC, it would not compile. Qt will replace it with some other for pre-processing. And by using this signals keyword, you declare a signal, but you don't actually need to provide a function body, as it's just a symbolic reference. And now interesting stuff, which is our send a signal. Here what we do, we emit the signal which will make the signal come into existence, so a slot can really take care of it, of the signal which is coming. So what will happen? What happen is that whenever you say emit sender number, this emit sender number, the compiler will substitute in the function for another object that you actually want to call. And then coming to slot, to declare a slot, that is a function which can be called in response to a signaling, you use a keyword that is slots. So you can have a class called receiver, which is public queue object. You have a queue object. Inside this you have a receiver, public, and then slots to receive. So this looks just like a normal class definition, but the keyword Q object, this Q object, and the fact that receive is defined not just as a public function. This is not just a public function, but as a public slot. So this makes, or this means that it is eligible to be connected with signal from another object as well. Then coming to connection, we can create objects of type sender and receiver now, but the sender cannot signal anything to the receiver here. There has to be a connection. So we would like now to connect the emission of this signal, which is happening with the emit signal. This was the emit signal and this was the receive for reception. So the syntax is quite simple. In main, you have to write this. You have to make sender S variable, receiver R variable, and just use Q object to connect this ampersand S, ampersand R. This is send, signal send int, slots receive int, and then S dot signal is signals Y. Connect is a static function in the class Q object, which basically means that it does not access any member variable. So you therefore don't need to have any actual object of type Q object, and you can directly call it on the class. It has 4 arguments, 1, 2, 3, 4, and this is the function. And finally, we'll call this s dot set signal because we have to send to receive. So these 4 arguments, the pointer to the object to which the signal belongs, the signal within the object, the pointer to the object to which slot belongs, here we have R, and finally the slot within the object. So what this function does is, when we have been talking about all along, it's basically replacing any occurrence of the line which is send, emit send n with receive n, and then exactly the right function will be called in the right places. So what happened in this code is that the number 5 is printed actually. So once you really understand why, you possibly get more and you understand this event based programming. Now putting all this together, this GUI layout and event based approaches are the key pieces we have known, but we need to think more about this. So getting at data from widgets now. First, how do you get information from the field of your form? For instance, suppose that you have a form with the OK button and you have some name or email addresses. Entering things by itself shouldn't trigger anything. You have to press a button, right? So when this OK button emits a signal, how can the corresponding slot know about the values of the text field? So the way we would do it to connect the signal that is emitted by a button to a slot in the main window. The main window contains all the other widgets, so it can query their contents and process them further, either itself or by calling another method that is just in charge of processing. So to see how to get the data inside your widget, you can look at the widget more closely. For example, if you have a QLine edit object for entering a string, it has a function called text, which returns the string you actually entered, and you can easily have this toStd string to convert it to a C string. And then control flow and main function. So what exactly does your main function do once you have written all these window signals and slots and connected everything up? You just have to write main and then Q application with a argument n and argument v, and my main window w, argument of constructor, and show it, and then just run a.exec. It's executed. So we assume here that you have written my main window class. So you've been using this class. Even if you generate your own window statically, as we are doing it dynamically, it isn't show until you tell it to, when you do it by calling a show. So Q application is a specific type of Qt object. This Q application is a specific type of Qt object, and you need to hash include Q application.h above it. Its job is to handle everything behind the scene for you. So what you do is to generate one of these objects and then hand over by calling its executing function a.execution exec. So at this point, Qt takes over and the button presses on Windows will call the corresponding function. This exec function will return a value based on what happened during this execution, and it will signal whether the execution was successful or not. Then coming to compiling Qt, because Qt is not exactly standard C++, so in order to do it, you can't just go for G++. but you first run it through a pre-compiler, which will generate a bunch of extra files for your code to incorporate all the windows and event-based stuff. And it also adds a bunch of code to work behind the screen or scene. So after that, you can run your normal compiler to compile a Qt program. We assume that Qt is installed correctly. You can call qmake project. Then this will actually scan the current directory for containing this Qt syntax and generate a platform independent file, generally a .pro. Then you call qmake. This will read this PRO file that Qt have generated or you have edited by your hand and generate a real make file for compiling your code and linking it to the Qt libraries. Then you call make. This will do the actual compiling and linking and reveal you if any error is there. And after debugging, you just need to run make again without the further 2 steps. And if you have changed some dependency, you may need to repeat the first step too. All these things you have to do. But if your program is debugged, it will run fine. So this was all about Qt, because we need to use Qt and C++ and other cross-platform stuff to actually implement our data structure. Thank you so much.